Hi, I'm Jimmy, aka Perceptes. Mutable Instruments Plaits, or Plats if you prefer, is probably the most popular module in Eurorack, and that's for a good reason. It's a great digital oscillator with many different algorithms, covering a range of sounds, using many different types of synthesis. Originally, it had 16 algorithms, but the final official firmware update in 2022 added a third bank for a total of 24 algorithms. And now in 2026, there's a new tool that expands the possibilities for plaits even more. A man named Lyle, who runs a small company called Rubato Audio, has created a web-based tool called Plaits Palette. It allows you to create your own custom firmware where you decide exactly which algorithms go into each slot. There are many algorithms to choose from, including all the official algorithms, the algorithms from Braids, Plaits' spiritual predecessor, algorithms developed by Rubato Audio, and others contributed by the community. It has a bunch more features beyond just picking and choosing algorithms too. In this video, we're going to take a look at Plaits Palette to get a sense of what it can do. We'll build our own custom firmware, flash it onto plaits, and test that it works. Okay, let's get started. Here's the user interface to Plaits Palette. You can find it on the web at rubato.audio/plaits-palette. I will link that in the video description and a pinned comment to make it easy to get to. So this is the basic user interface. The main panel that we see here at the top is what you use to arrange which algorithms you want in which slots on the firmware. We have the green bank, the red bank, and the amber bank, which are the three banks that we have out of the 2022 official firmware. But Plaits Palette also introduces an orange bank that you can fill with an additional 8 algorithms if you like. Now there is a limit to the amount of flash storage on the device, so some combinations of algorithms may not be possible to put on the device all at the same time. And this handy little bar here will give you an estimate about how much memory the algorithms that you've selected will require on the device and whether or not they will fit. So you can click on each of these individual algorithms, and this little bar at the top will give you a description of what it does, and you can use these buttons to sort of rearrange them, and they will correspond to the lights on the panel of the module. We also have the full list of available models or algorithms in this bar on the right, and this includes all of the different models unless you search with the box at the top or you pick one of these tags. So you click on Mutable Instruments, and then you'll get algorithms that are only from official Mutable Instruments firmware, including the original Plaits algorithms, and if you scroll down, you'll see the Braids algorithms as well. Rubato Labs has created their own algorithms that you can try, and you can see there's quite a few of them to pick from here. And finally, there's community contributed ones, which are from third parties, not Mutable Instruments or Rubato Labs. If you click on one of these little chevrons, it'll open up a box that has additional information about the algorithm, including a longer description of it and an explanation of what the different controls will do in that algorithm on the module itself. So it explains harmonics, timbre, morph, and there's now a fourth control called macro, which is specific to Plaits Palette, and we'll get into details about how that works in a minute. But each one of these algorithms under Plaits Palette actually has 4 different sort of macro controls, with the fourth one actually being called macro. It then tells you what the main output does, what the auxiliary output does, and what happens when you send it a trigger. You can even click this preview button, and it'll give you an audio sample of what the algorithm sounds like. Similarly, you can click the little play button on the algorithm in the list on the left, and that will play the same preview. There's also this little icon with the 2 circles interlocking, which indicates stereo. One of the cool things that Plaits Palette can do is that it can give you stereo versions of each algorithm. So rather than having a mono out from the main output and sort of a secondary related sound from the aux output, it can actually use those as sort of a dedicated left-right for a single sound to give you a stereo image. So if you click on the stereo button, you'll see that it toggled it both in the model library and in the palette that we're creating over on the left. And now if I click one of these preview buttons, we'll hear the stereo version of that. Some of the third-party algorithms are always stereo, in which case this button only affects what you hear in the preview, but it will always take up the same amount of flash memory because it's always stereo. So if you want some different ideas about which ones to try, there are a couple of presets that are up at the top of the palette. I have the stock one loaded, which are the ones that are on the official firmware, but we can click Experimental, which will add some additional ones from Rubato Audio in the fourth bank. We can also try Stereo Dreams, which will give you dedicated stereo versions of each of these. You can try Braids, which will load all of the different Braids algorithms onto the different banks, or you can just do an empty preset and drag in exactly the ones that you want. So you just drag them over and drop them wherever you want. You can also click on an empty slot, and then if you add a particular one, you just click on it and it'll put it in the slot that you currently have selected. If you come up with a palette that you like and you want to be able to recall it later for further editing, you can click on this Save Configuration button, and that will download a file to your computer, which you can then reload at any time by clicking the Open Configuration button and loading that file from your disk. You can also manage the FM banks from Plaits Palette. So if I click on one of these FM banks, you can see that there's this Customize Patches button that appears in this top bar. And if I click on that, then we get this library of different DX7 SysX patches. And there's quite a lot of them. Looks like 3,500 different patches here. And so you can build your own DX7 bank in here and use that as one of the banks on one of the DX7 banks on Plaits. One of the things that was added in the 2022 firmware update is that 3 of these Amber algorithms are banks of DX7 style FM patches. And there's a official web tool that you can use to override these different banks with your own custom algorithms. And this is another way that you can do it as you're building your Plaits firmware with Plaits Palette. And this also has previews, so you can press these little buttons to hear what they sound like. Really useful. This on its own, I think, is a great feature. If we scroll down from the palette section, we'll see some of the other things that Plaits Palette is able to do, which is really quite incredible. The first one is it allows you to choose multiple chord tables. So the original Plaits firmware has one chord mode, where the chord is determined by the position of the harmonics knob. And the chords that are played are based on what the position of the knob is, and they go in a certain order, and it's always the same. But this chord table selection system allows you to create your own custom chord sets that have very precise control over what the exact chord voicings are for each of the 4 voices that makes up a chord as you turn the knob. So you see here is the original one that shows the order of the chords that appear on the original chord model. And then by default, there's a few other ones that have sort of different LED indicators, and we'll see how that works in a minute. So you can click over some of these other ones, and you can see the ordering of the chords that's provided there, along with a text description of sort of what the general idea of that chord group is. You can click through them like this. You can add additional ones by dragging from the table palette over here. You can preview the chords, and you can use different sort of audio sources for the preview. So let's listen to the string machine, for example, for maybe the Disastrous Peace example. So you can see that that has a lot more chords in it than the original one does. And you can add a chord by clicking this button, which will add a new row. And this will just change the amount of voltage or the position of the knob that's required to land on a particular chord when you're using it on the module. And as you can see, you have very precise control over exactly the intervals between these 4 voices, and you can change them in Sense by changing the numbers in these boxes. You can also export chord tables to use another time, or submit them to the library if you come up with one that you think is interesting. If we scroll down some more, you can see that you can also customize the speech models, because there's a model on the original firmware that does speech simulations where it says words in sort of a pseudo-human-like voice. So you have sort of the same amount of control as you do with the chords, where you can customize specifically which words are spoken and what they say and kind of the nature of the voice. You see if we drop down the voice, we have a few to choose from. So we can try, for example, Michael, and then listen to a preview of the voice.
The singing voice approached rapidly.
And so for each one of these speech banks, We can change what the words that it says are. We can add custom banks. We can save them. We can set the pronunciation override to change how it says a word if it gets it wrong. And you can even click on this little tab to use a recording of your own voice as the basis for the speech engine, which is pretty incredible. Finally, there's a section at the bottom for firmware options, and this allows you to control a couple of different things. The first is the way that the models navigate, and this is something that Plaits has been able to do by itself since the 2022 firmware. In the original version of the firmware, the buttons would navigate to the next sort of bank in series vertically going from top to bottom, and pressing the left button would select green banks and pressing the right button would select red banks. But when the third amber bank was added, there was a new feature where if you press the two buttons at the same time, it would switch to an alternate navigation mode where pressing the right button would advance to the next one, regardless of which bank you were in, and pressing the left button would go previous. And so this would allow you to just sort of cycle linearly through all of the models of all of the three banks. So this allows you to choose which of the two navigation methods is used on your custom version of the firmware. Probably you want to leave it in this previous next mode, which is sort of the modern way of doing it, and that gives you access to more than two banks. Finally, something that's really interesting to me is this starting options section. Plaits Palette gives in a bunch of additional settings for what different parts of the module do, and you can set here what they are by default, but after you flash the firmware onto the module, you can actually change them after the fact by pressing the two buttons at the same time to get access to a menu that controls all of these things. So you can see that there's 8 rows here in this little list of options, and that corresponds to the 8 LEDs on the Plaits hardware. And so when you press the two buttons on the hardware, you will get 8 lights that correspond to these colors. So the chord table is what we saw above, is which chords are set by the harmonics knob when you're in one of the chord modes. You can click through and you can pick any of the chords that you've assigned to your chord table by clicking through this, and you can see that the LED color changes, and some of them may blink to distinguish which one you have selected. So when you're in the menu, the left button will move you to the next option, and the right button will cycle through the options that you have currently selected. For the aux output, the default and the original behavior is that there's sort of an alternate model, something that's related but not exactly the same as the main output. Another option is to do stereo, left, right, and what this will do is it'll be a global override where all of the models that are installed onto the module will be output in stereo with left, right instead of a sort of a primary and secondary oscillator coming out of the main and aux jacks. You can still use those stereo buttons in the actual palette editor at the top to set per model which you want to be stereo and which you don't, but at any time you can also turn this on to stereo mode and then get a stereo version of all of them. You can also select sub-oscillator, which will cause the aux output to output a single oscillator that is below the root note that's being played by the primary one. And when you have sub-oscillator selected, then this next option becomes available that allows you to choose what type of sub-oscillator you're going to be using. So you have a regular square wave, you have another square wave but an octave below, or 2 octaves below. You can also have a sine 1 octave below, a sine 2 octaves below, and then you're back to square. And notice again that each one of those has a different sort of color pattern on the LED, so you can distinguish which one is which. Next, we go to the locked frequency knob. Now this is really interesting because this is one of the ways that you unlock that 4th macro parameter, which is added by Plaits Palette. By default, when you're in the sort of shifting octaves mode, which is where you hold the right button on Plaits and you move the harmonics knob, I think it's the second to highest or the second most clockwise position, will allow you to sort of set a base frequency. And then when you turn the frequency knob, instead of doing fine tuning, it'll just jump between different octaves of that same pitch so that you don't accidentally detune your oscillator during a performance or something like that. But what this does is it allows you to switch it away from that behavior. So if I click here, then we go to macro 4th control. So that means that if you go into sort of the usual locked frequency control, then the frequency knob on the module actually becomes that 4th macro control. And you'll have to look in the description to see what the macro control does for any given algorithm. If you set it to this mode, you can still change the frequency, even though you no longer have access to the frequency controls. And you can read the details for how that works. But I think you hold the right button and then turn the morph knob, and that'll allow you to still change the octaves like you could before. You can also set the frequency knob to do an aux crossfade. I guess it's crossfading between the main and aux outputs, but on the main one. You can also have it control the decay of the built-in envelope, which is not something that you've had CV control over previously. You can also cause it to affect the triggered envelope, or a gated envelope, or back to octaves. You can also control what the model and level inputs do. These are the CV inputs on the module that usually allow you to change the algorithm or the volume level of the output wave. So you can change the model input to be its default, which is model, or you can have that be the macro control. So you can send a CV signal into that and use an external voltage control to give you that macro control performance without changing the behavior of the frequency knob. You can also use the aux crossfade on this CV input. You can change the LPG color, which again is something that has not been CV controllable previously. This is the thing that allows you to blend between a low pass gate and a full VCA with no filtering. And then back to model, which is our default setting. For the level input, the level is the default, which again is the amplitude of the output. You can also change the decay of the built-in envelope, or you can do this sort of auto mode where it'll either do the decay or the velocity, depending on whether the particular model that you're on has some sort of built-in envelope involved with it. And then back to the level. It also has a sort of sample and hold feature with this hold parameters on trigger, which is just an on or an off. And what this does is that every time the module receives a trigger, it will sort of freeze the settings of where the different macro controls were at the moment the trigger happened, and that note cannot change while it's ringing out until another trigger comes in. So that's a really nice way to do sort of like sample and hold on all of the different parameters on plates if that's what you want. And finally, our last option is unpatched attenuverters. And this is the little small pots that are below or above the CV jacks on the module that allow you to attenuvert the incoming CV signals. By default, what they do is they apply a bit of change to the control that they're associated with that's aligned with the envelope that's used for the audio. So if there's like a short sort of like an instant attack and sort of a short decay, that same envelope will be applied to, for example, the timbre or the morph. That's how it works by default. But what this adds is something more similar to the way beads works, where you can set it to continuous drift, where the values are sort of constantly changing, and the amount that they change is determined by the position of the potentiometer. So if you turn it one direction, it'll get very random and sort of wild, and you can turn the other direction for still constant changes, but ones that are sort of where the movement is more restrained and sort of close to what the knob's default setting is. There's also a triggered random step version of it, which will cause it to sort of pick a different value on the different triggers. So that's kind of like the hold parameters on trigger option above, except it relates to the sort of auto modulation of those different CV controls. There are some advanced options here that will allow you to do some other things like building this for the Plum Audio Roved version of Plaits, which is sort of the 1U version that's slightly different. You have the color blindness sort of UI where the lights are changed so that you don't have to be able to see the colors, and some other details down here, which you can check out at your leisure. And at the bottom, finally, we have some overviews about what we've built here. And then we've got a button that will actually build a WAV file, which is what we use to flash it onto the module, and the installation instructions with a link to the manual for all of the details about how you actually flash this. But I will show that to you right after this. Now, for me personally, this is kind of a blessing and a curse having this tool, because I think one of the challenges of Plaits is that it has so many algorithms and all of the controls do something different in each algorithm. So it's kind of a lot to remember. And I find personally that I end up using the same few algorithms all the time just because they're the ones that I use often enough to remember and I don't have to refer to the manual every time. So being able to customize it like this is wonderful because it opens it up to do exactly what you want, but it also means that the labels on the panel will further sort of distance from what it's actually doing in any of those given slots. And so I think that may be kind of a drawback unless you want to have the manual right next to you. So the way that I'm going to set up mine personally is I'm just going to replace two of the stock algorithms. I'm going to replace the inharmonic string and the modal resonator. And that's because these are sort of simplified versions of the models that are in Mutable Instruments rings. And I have the real rings. So these are actually superfluous for me. I don't have a reason to use these because I could just use the real rings. So what I'm going to do is load a couple of the braids firmware or algorithms onto this. So I'm interested in doing more of the sort of physical modeling type. So I think I'm going to do maybe the blown algorithm from braids instead of the inharmonic strings. And then I'm going to do the fluted algorithm over the modal resonator. So that's going to be my customization. Everything else I'm going to leave the same. Let's try building it now. So if I click on Build Firmware Wave, you can see at the bottom it says Submitting Firmware Recipe. Your build is queued, and then it takes a few seconds, and then you'll get compiling and validating firmware. And finally, it will download the file to your disk after a few more seconds. And a thing that's really nice is that will also give you a matching field guide. So if you click on this little button, it'll create a PDF that has an explanation of all of the algorithms that you have loaded with all of the controls that you've selected and all of the options specific to your custom firmware. So you can use that as the reference to remember exactly how you have things configured. Okay, let's switch over to the actual hardware now. We're going to flash this onto my plates and make sure that this actually does what it says it does. Okay, here is my modular case that includes Mutable Instruments Plaits right here. And we're going to flash the custom firmware from Plaits Palette onto it. So on the back of the module, I have a line level signal coming from my computer going into the 1/4 inch jack that feeds into the IntelliGel stereo I/O, but we're just going to use one channel of it because it's a mono file. And I'm going to take the left output. We're going to patch it into the model input on plates, make sure that all of the knobs are at their sort of noon positions, and then we're going to turn the module, the power to the module off. We're going to hold the left button and turn the power back on, and we will see these 4 flashing orange lights. And then I'm going to play the wave file on my computer into the model input. When you do this, make sure that you have the volume to your speakers or headphones either off or very low, because it's a very loud, aggressive sound and you don't want to hurt your hearing. But I will include a very quiet version of it so you just can hear what it sounds like. Now, as soon as you start playing back the audio file, you'll see the lights on the module start to change. The bottom 4 that are blinking are showing that data is being written onto the internal flash memory, and the top 4 are sort of like a VU meter that's showing the level of the audio that's coming in on the model input. The manual says that you want the lights to be lit kind of like between the top green one and the yellowish amber one to sort of be the optimal level. But I found that I actually need it up a little bit higher so that that red LED is lit. Otherwise, the firmware flashing operation doesn't succeed. If you see all of the lights flash red, then that means that it didn't have a strong enough signal. You can press the left button to start again and just either turn up the external signal level, or you can use the frequency control as a gain control. Turning it clockwise should increase the gain on the input. So this takes about 3 minutes, and when it's done, the module will automatically reboot with the new firmware. Okay, there we go. It finished and it rebooted, so now we should have the Plaits Palette firmware on there. Okay, so let's move over to one of the algorithms that I changed, which is that first rings model. We've changed it to the blown algorithm from braids. So I'm going to plug the output into our left out. And sure enough, that is not a rings model. That is a braids model. So it did in fact flash these. I realized that in the starting settings, I forgot to change the default for the frequency knob to be the macro control, but we can edit the settings on device. So if I press both buttons at the same time, then we get this menu Where the fourth LED is highlighted, that's the control for what the macro knob does, or what the frequency knob does. If I press the right button, we'll see that LED change to red, and now it's controlling the macro. So if we plug this in again, listen to that braids model, and we can still change the frequency octave by holding the right button and moving the morph control. Then I can change that macro control with the frequency. See, it's changing the timbre of the sound and not the frequency. I hope you enjoyed this video, and I hope it got you excited for the possibilities Plaits Palette gives you for making plaits your own. If you use Plaits Palette, consider making a donation to Roboto Audio to support its development. If you found my video useful, you can support my work as well over on Patreon. You can join for free for updates about new videos and live streams, or chip in a few dollars a month for a bunch of benefits, like patch notes and project files for my educational videos, high-quality audio downloads of music from the channel, sample packs, full access to the community Discord server, and more. Thanks so much for watching. I'll see you next time.